is our second lesson on the topic of quadratics, or graphing parabolas. First, we're going to look at the zeros. Now, the zeros, in the past, we've talked about 0 for y, and that gives us the x-intercept. Oh, look, here's another one, 2 x-intercepts. But we are not going to deal with this 0 when we're talking about zeros. This is our y-intercept, and when we speak of zeros and quadratic functions, we are not talking about the y-intercept. We are simply looking for the x-intercepts, if any. So, for instance, as we look at this parabola here, this is a 0. It's -4. And here is a 0. 2. We're not concerned with whatever this is. So we're going to check our zeros to see if indeed this -4 here in our table is a 0. You can see we're substituting in our original function here what we think is a 0, -4. And you could see in the table it's supposed to equal 0. Well, let's try it. Does 0, let's put a question mark here, equal, well, -4 times -4 is a positive 16, and 2 times -4 is -8, and then the -8. And you can see this checks out. 0 equals 0. This is how we would test by looking here. If we didn't have the table, we could look here and say, does -4, is that really where the 0 is, or is it maybe 4.1 or something like that? We can test this -4 in the original function and see that it does indeed give us a 0. Now, if we were looking at the table, say in a calculator, you can see that the 0 is associated with the -4. But it's always good to be able to check things algebraically. Let's check this other 0. We think the other 0 is 2. Let's check 2 in the original function and see if indeed we get a 0. So we're going to put a question mark here. Does 0 equal 2 times 2 is 4, plus 4 minus 8? Yes, that is a true statement. 0 equals 0. So we would say -4 and 2 are the zeros for this function. But there aren't always zeros. Here's why. Here we have a parabola that is not going through the x-axis. Now, if it's flipped around, oops, then it would have to be in one of these other quadrants in order for it to not touch the x-axis. This parabola anywhere up here would not have any zeros, but also if the parabola were down in here, it would not have any zeros. It'll always go through the y-axis, but we don't call those zeros. We only call the x-intercept zeros. So to find the axis of symmetry, that's the next most important thing that we're going to learn today. Zeros and the axis of symmetry. Next, we're going to find the axis of symmetry. The axis of symmetry is a line that divides a parabola into 2 equal halves, and so that if you folded the parabola in half, one side would meet up with the other. It's always in this form, x equals, because x is staying the same all along this line. In this case, x equals -1. So if I were to write the equation for the line of symmetry, or the axis of symmetry, I would say x equals -1. Here's some more examples. In this case, the axis of symmetry would run down this way. And we would say that line is x equals 1. In this case, we're 1, 2, 3 over. And the equation for this line of symmetry is x equals negative 3. For this particular parabola, though, it would be very difficult to decide what exactly x equals there. And so we have a formula, and it was on your homework right after the test. The formula is x equals, and then we take negative b over 2a, where b is the coefficient in front of the x, and sometimes this term isn't here, and then it's just 0. But in this case, there is a coefficient in front of the x, and it's negative, it's 5.3, but b is negative. So there's b, and there's negative b. And then 2 times a. Well, a here is negative 1. A is negative 1. So then the equation of the line of symmetry is x equals negative. Oh, I guess it'll be positive. 5.3. Here's some more practice from your homework. Here's A. B is 1. And we don't care about C. The equation for the line of symmetry is negative b, negative 1, over 2a, or 2 times negative 3. So we would write the line of symmetry is x equals, and it's negative over negative, so it'll be positive 1 over 6. Now that we can find the axis of symmetry, it's very easy to find the actual vertex, or the minimum or maximum point on a parabola. Now we're going to learn to find the vertex of a parabola. Remember, the vertex is the minimum or maximum value of your function. And you will notice that the axis of symmetry goes right through the vertex. So the x value we can pick out as being x equals from the line of symmetry. And then we'll substitute the x into the original equation to find the y. So for example, if you have this equation, you can easily find the vertex by looking at the line of symmetry. Your line of symmetry is x equals negative b over 2 times a. And a in this case is 1. Negative b over 2 times a. So x equals negative 4 over 2, which is the same as negative 2. So the equation for the line of symmetry then is simply x equals negative 2. But that's also the x value for your vertex. Here's x. Now we have to find y. We find y by substituting in the original equation. We're going to substitute the x value in the original function to find y. So copying the original function with our x value of negative 2 substituted for x. So negative 2 squared plus 4 times negative 2 minus 7. And then we simplify by order of operations to get 4 minus 8 minus 7 which is negative 11. That's negative 15 plus 4, negative 11. So we think that our vertex is negative 2, negative 11, and the wise student will take their graphing calculator and make sure they've calculated correctly. I've put the original function here into the calculator. Have a look. Here's our original function. You can see it. X squared plus 4x minus 7, x squared plus 4x minus 7. And I graphed that, and I hit the trace button. And we can see right here, we're getting close. We think it's negative 211. Let's look. Well, there's the point right in the calculator here, negative 211. And on the trace button, we're almost there. There it is, negative 2, negative 11. And that does indeed look like the lowest point on our parabola. Here's another example. Our axis of symmetry is x equals negative 6 over 2. Now a is negative 1. So our line of symmetry is negative 6 divided by a negative 2. That's going to be a positive 3. Then to find well, that's our x-coordinate. To find the y-coordinate for our vertex, we substitute this x equals 3 in the original equation. So I'm just going to write it under here for convenience. And I get y equals 3 times 3 is 9, but then you're taking the negative of it. Careful with those. 6 times 3 is 18 plus 1. So that's y equals 10. Now, since the coefficient on x squared is negative, I expect to see a frowning or upside down or opening downward parabola when I graph it. Here I show the grapher with the parabola as expected. The vertex is at 310, and it checks out 310, and that looks like about 310 by looking at it. Life situation that helps us envision what this is all good for with graphing parabolas. You have an entry path for a particular swimmer. He dives into the water at this point here. This would be where time equals 0. And say his path is modeled by the parabola t squared minus 3t for the domain of 0 to 3 seconds. So here's the domain 0 to 3 seconds. The pool is only 2.5 feet deep. Can this swimmer safely enter by diving? Well, what you want to know, if the pool is only 2.5 feet deep, it looks like he would have some clearance there. By finding the vertex, you could actually figure out how much clearance he has. So let's look for the vertex. The vertex is at negative b over 2a. That's the x-coordinate. It's negative b, so that would be a negative 3 over 2 times a, and a is 1. So our x value for our vertex is 3 halves. See, does that look reasonable here? Yeah, 1.5. So our line of symmetry is coming through here like this, 1.5. Now let's find the actual vertex here so we can tell how deep he is. So we get y equals, now remember the vertex is an xy coordinate. So here's our x-coordinate for the vertex, and now we're going to find y by substituting 3 halves into the original equation. So I have to square this whole thing. And then it's minus 3 times, once again, our x value, 3 halves. And we'll solve for y. Well, let's see, this would be 9/4. Y equals 9/4 minus 9/2. Getting a common denominator, we have y equals 9/4 minus 18/4, which is negative 9/4. Negative 9/4 is slightly over negative 2. So, to answer the question, how much clearance would he have between 9/4 and 2.5 feet deep? 2.5, that's 5/2. And if we subtract his diving distance, which is 9/4, we'll see how much clearance he has. This is 10/4. Take away 9/4, that's only 1/4 of a foot. He only has 3 inches clearance. 3 inches clearance. The difference between the 5/2 feet the pool is and his typical diving distance of 9/4. That isn't a lot of clearance. He probably shouldn't dive.